So today we are learning how to rationalize the denominator, and versus recreate an entire video, I just wanted to go off of the examples that were already in your book and try to explain them a little further. So we start out with this 3 over 2 square root of 5. Now, the reason this is a problem is because we can never have a radical in the denominator. So the 2 is not the issue. The square root of 5 is the issue. And the only way to get rid of a square root is if I have its square. So what they did here was they multiplied by the square root of 5, and whatever you do on the bottom, you have to do on the top, okay? And when I did that, I created a perfect square. 5 times 5, they did this right here, this would give me the square root of 25, which is just 5. Now I've eliminated it in the denominator. Now it didn't eliminate it here, just in the denominator, because that was my problem, okay? All right, and then I'm just going to clean that up. 2 times 5 is 10. 3 square root of 5. Remember, we talked about breaking down that radical using tree method or perfect square method, but 5 is prime, so he's done. Okay? All right? Now, B is very similar to A. It just looks different because they've put that whole fraction under the radical. But you can actually write that as 2 separate radicals if you would like. Okay? All right? Now, I maybe would do this a little bit differently than they did. I'm trying to think here if I can get a pen. Just a second. You bet I can. Okay, so if I was going to do this, I would probably write this as, helps to have a pen. Right? No. That's not what I want. Okay, just everybody calm down. How about this? And I want black. Okay, I think we're getting somewhere. Okay, so I would write this as the square root of 1 over the square root of 8. Okay, then I would tell myself, can I simplify those two things? Do I know anything about them? Well, I know the square root of 1 is 1. So I might as well just take care of him from the start. That eliminates that radical, and then I don't have to worry about him. Okay? All right? I also know that the square root of 8, if I tree method him, is two square root of 2. Now again, just like this one up here, the 2 out front is not the problem. The radical is the problem. So I want to create his perfect square. And by doing that, I'm just going to multiply by the square root of 2 on the top and the bottom. Okay? That's going to give me 1 square root of 2. I don't even need that 1 anymore. And then I have 2 out front. And this is now square root of 4, which we know what the square root of 4 is. That's just plain old 2, right? So now I have 2 times 2. And that gives me square root of 2 over 4. Now, I cannot reduce these because this guy isn't in a radical. This guy is done because 2 is prime. And you'll see that we got the same thing that they did. Okay? All right? Now, let's say that you didn't know. I'm just going to go back a couple steps. Let's say that you didn't know that square root of 8 simplified. Okay, let's say you didn't do tree method. Don't freak out, all right? We can still know that square root of 1 is 1. Let's say, man, I just don't know if square root of 8 can be simplified. You could still create his perfect square right here. And you could say, let's multiply by square root of 8. Okay? That's going to give me the square root of 8. Oh, so sorry, this is so messy. Over the square root of, wouldn't this be 64? Which we know is plain old 8. Okay? Now, at some point, you're going to have to tree method. So now that I think I've gotten rid of that radical on the bottom, then I have to go back and look and see, can I break these radicals down? This guy is obviously fine, but this guy right here, then I would tree method him and say, oh, I remember now. This is 2 square root of 2. Okay, whoops. And then this right here can reduce, not the root, but the numbers that aren't in the root, to give me square root of 2 over 4. Okay? All right, so like I said, don't freak out. If you would rather rationalize first and then take care of your radicals, as far as simplifying, that's fine. If you want to simplify first, that's okay too. Okay? That's all right too. So, hello.
Gee, you still working here? I haven't seen you for a long time.
I know, I'm still here.
I'll be darned. Thinking about making it a career, huh?
I guess so. I guess so. I'm making a video, so you just got on the video, Bill.
Oh.
That's okay. All right, guys, let's go on to the next page. You're fine. All right, so for the next page, we have more than just one radical in the denominator, okay? So we can't separate these out. We can't just say let's multiply by the square root of 3, because we know that with addition and subtraction, we can never just separate them. They are a set. So what they do is they multiply by something called the conjugate, all right? The conjugate. And the conjugate is the denominator with the middle sign changed. So you'll see they did that in blue, and they did that on the top and the bottom, because whatever I do to the bottom, I have to do the top. All right, so they're going to take everything times -4 minus square root of 3. I like it better in this step right here, because you can actually see these are sets, and we know if we have a set times a set, we have to FOIL. If we have a number times a set, we have to distribute, and I'm going to kind of show that. They really didn't do half bad at showing you guys, but I'm going to show you anyway. Okay, so if I was going to distribute this, this would be -8. This would be -2 square root of 3 all over. Then I have to FOIL, so first outside, inside, last. 16. That'd be a +4 square root of 3. This would be a -4 square root of 3. And this would be a negative square root of 3 times square root of 3. That'd be square root of 9, which we know is -3. Okay. All right. Now I just need to clean this up, okay? I'm going to leave the numerator alone, which is what they did right here, -8 minus 2 square root of 3, okay? Then here, these can cancel. So that's where they got the 16 minus 3, obviously 13, okay? The only way this could go further is if all 3 of these numbers could cancel by the same value, which they can't. 8, 2, and 13, no number could come out of all 3 of those. So you know you're done. Okay, and that would be your final answer. Okay? All right, here comes another one. All right, so this time we have 3 over the square root of 5 plus 2. Again, we can't separate those. You'll see that they multiplied by the conjugate. I like how they put it in sets so that you can see you need to distribute and you need to FOIL the bottom. That foiling is going to get a little bit ugly, but stick with it. So I'm going to go ahead and distribute. 3 square root of 5 minus 3 square root of 2. Okay, so the distributing was easy. All right. Now when I'm foiling, square root of 5 times square root of 5, that'd be square root of 25, which we know is 5. So you might as well just use that. Then we've got square root of 5 times negative square root of 2. That's negative square root of 10. And this right here, 2 times 5, that'd be positive square root of 10. Handy how those are canceling out every time, right? And then square root of 2 times square root of 2, that's square root of 4. So I just have -2 there. Remember, these are going to cancel. Okay, can I subtract these two guys? I hope you're saying no, because they don't have like radicals, okay? So they have to stay. Now, see how they kept this in this distributed form? I guess, I mean, You can. Or, I mean, in this factored form, you can. I mean, when I look at this, guys, I'm going to say, well, here's 3 square root of 5 minus 3 square root of 2, and that's all over 3. Remember what I said on that last one? We're not looking at the radicals, but if all of these numbers, okay, if these 3 numbers can reduce, then do it, okay? All right, and that leaves us with the square root of 5 minus square root of 2. So to me, I don't think it's a big deal to factor if you can recognize that and say, okay, I've got to make sure all 3 of these can reduce if I'm going to do it. Okay? Okay. All right, we've got one more bad boy. Okay. All right, so this one's a little uglier, okay, but still the same principle. You'll see that my denominator is 2 minus 3 square root of 3, so I'm going to multiply by 2 plus 3 square root of 3. Now, check it out. You've got sum and a difference. You've got addition and subtraction in both the top and the bottom. That means you're going to have to FOIL the top and you're going to have to FOIL the bottom. Now, I feel like they did a better job of showing you this here, okay? So 4 times 2, 8, okay? Sorry, it should be down here. 4 times 2, 8. 4 times 3 square root of 3, 12 square root of 3. 2 times square root of 3, 2 square root of 3. And then square root of 3 times 3 square root of 3, that would look like this, guys. Okay, 3 times square root of 9, because we know square root of 3 and square root of 3 is 9. Well, this is 3, so then 3 times 3 is 9, which they bring down to this step right here. The other thing they've done from here to here is just combined like terms, because notice they have the same radicals. So 12 and 2 gives me 14, okay? On the bottom they FOILed just like we did the last one. Remember, the middle terms will cancel in a conjugate. So 2 times 2 is 4. The middle's canceled. Then we've got this 3 times square root of 3 times 3 square root of 3. It's the same thing as it was here, except we'd have 3 times 3 times square root of 3 times square root of 3. Well, this is 9, and this is square root of 9, which we know is 3. So 3 times 9 is 27. Okay? Now, at this point, they combined like terms one more time. 17 plus 14 square root of 3. Remember, I'm looking at these guys right here, and I'm saying, can they reduce by the same number? No, they cannot. So I'm done. Okay? Hooray! Good luck.